Good morning. I hope you're doing well. I am doing fairly well. I'm having a bit of technical difficulties with my camera that I normally use to show Jugglebot view, so this may be a little bit annoying today. I'm hoping that it's just, I don't know, having a bit of a hissy fit and that it will start to work soon. But if not, we will have to make do with just this camera, and I'll show you what I've got with that. Such a hassle. This week has been an interesting week with lots of software stuff happening and so much head scratching and just like, it's driving me mad. But things are working and it's very good, and I'm very, very keen to show you what I've got. I've had some realizations in the last 12 hours about how I can do how I should be doing some of the things that I will talk about today. And yeah, so there's a couple of improvements that I want to make on what I'm about to show you, but on the whole, I'm quite happy with it. I'm glad that things are working the way that they are. And I hope that you're doing well, as always. Yeah, cool, so let's get into it. So, turns out, last week I mentioned that there's another CAN problem, which is that the ground wasn't connected between my, like for the coil cable that I was using to connect the hand to the base. But it turns out that wasn't a problem after all, and my cabling was actually good. I didn't have any issues with that. The problem is that for ODrive Pros, the DC negative power, like the power that's going in for the motor, needs to be connected for CAN communication to work at all. Now, in the ODrive docs, they do say that if you want to use CAN with the ODrive Pros, then you have to have DC negative attached to CAN negative somewhere on the bus. And I don't have a picture of my circuit diagram. Actually, yes I do. Let me show you my circuit diagram while I'm talking. Yeah, I do have that connection somewhere, but I didn't think that it was necessary for CAN to work at all. I thought that that was just necessary for, like, if you're using CAN while powering the motors and everything, while the robot's in actual operation, I thought that's when you need to have them connected. But it turns out you actually need them connected. You need DC negative connected to CAN negative all the time. I can't remember where, it's a bit annoying to find that actually, so I won't actually show you that. But it's on GitHub. If you want to see the circuit diagram, you can see it on GitHub, and there's a little connection connecting the two negatives. So, and that turns out that's actually why, I mentioned last week that when I touched the outside of the USB-C connector to the port, that's when the ODrive like lit up and was like, hey, I'm alive. That's why, because that ground of the USB-C is connected to the whole DC negative thing. So that, like, as far as I'm aware, that is what completed that circuit and like allowed it to work. Yes, but I only discovered this after I cut the cable. So I cut the cable and then I measured the continuity between ground in the plug and like the cut ground. And I was like, cool, the connection is solid on the side that I want to keep. And then I'm like, just to be thorough, just to be rigorous, I'm going to check the connection on the other side as well, the side that I like discarded. And that connection was also solid the whole way through. I'm like, what the heck? Like, turns out the cable was actually fine. But as I mentioned last week, I actually wanted to cut that cable anyway, so that it's a lot, so that there's not as much cable just like lumped on the ground, sitting there doing nothing. And I wish I could show you. Hopefully this camera sorts itself out in the next couple of minutes. But it looks a lot cleaner now. There's just the right amount of cable so that when Jugglebot moves up, it's still noticeably a coil, but it's all off of the ground now. And even in its lowest position, like there's very little excess sitting on the ground, which is very nice, very aesthetically pleasing. Yes, I want to do that anyway. Cool. So, first thing I did this week is to update all of the code to match the new geometry of the platform. And this was fairly straightforward, but the annoying thing is that I was trying to find the clip of me saying this. I can't remember where I said it. I'm pretty sure it was in one of the live streams, but I couldn't find it last night. But at some point recently, I had, like in the last couple months, I had changed all of my code over so that whenever I'm controlling Jugglebot with like my space mouse or with the jogging or anything like that, it was actually controlling the hand. And if you remember the way that the hand was strung up before, it had a fairly, I don't know, non-obvious like routing with the string. And so what I was doing is I had changed everything over so that when I controlled when I gave it a position, that's actually the position that the hand would be at, and the rest of the robot would figure out where it needs to be to get the hand into that position. And this is frustrating, well, was frustrating, because now the hand is completely independent. It's just doing its own thing, and it's being moved around by the platform. And so I had to get rid of all of the updates that I had just done, like somewhat recently, and change them all back to just controlling the platform. And yeah, so that was a little bit tedious. And one thing that I'm curious to know, if anyone has any suggestions about this, is how to get this. This seems obvious because like Onshape is obviously like it's CAD, so the geometry is just like in there all the time. But there's a particular geometry that I needed for updating my my geometry code, which is I need the radius of the base, which is actually unchanged, and I need the radius of the platform. And in SolidWorks, the way that I did this is to insert like a part into my assembly, and then that part was just a sketch, or two sketches. One sketch was the base circle, and the other sketch was the platform circle. But it's not as easy to do that in Onshape. Like I've made a part called Geometry Sketches, which is just these two sketches, and I've brought them in. But when I bring both of those circles in, so if I've got like one for the base and one for the platform, when I bring both of them in, it got, I can't remember what the actual problem was, but it was actually, no, that was it. It was really tricky to mate the top circle. So this top circle is separate from the bottom circle because you can't have 3D sketches in Onshape. So these are two separate ones. And yeah, I can't mate this to the platform in a way that makes sense. Like I created it in this context, but when I bring it in, I can't mate it using the same mate connectors that I used to create it in the context because it just didn't let me. It was, I don't know, it was really strange. Yeah, it's very odd. And so I was thinking like, okay, cool, this works right now. I can just have the base circle sketch, and now, so we can see like this is off when the platform is off at some angle, but if I update this context, which is itself a bit annoying to do, updates, now it's flat. So now this sketch, like the platform sketch in particular, has updated to match what the assembly is doing. But if I delete this part from here, then these contexts are still here, but I can't update the context anymore. I don't know, it's very weird. I wish that I could have sketches natively in an assembly. If I could have a native sketch, that would be really good. If anyone has any ideas of how to do this or what you think you would do, the basic idea is that I want a circle, so there's one here. I want this circle to go through all of these joints. And so I've got mate connectors. This is the other thing, if you show the mate connectors, you show all of them. And I wish there was a way to just like show, like have a selection of like, I want to show only these ones at a time. But yeah, so it's going through all of these mate connectors in well, 3 of the mate connectors in these spheres. And then the platform one, which I don't have in the assembly because it couldn't mate properly, but it goes through like basically the same thing, like the center of here, essentially. Yeah, I don't know. If you have any ideas, like if you have any thoughts about what you would do there, then I would love to know. Because this works, and I only need to do this once, so it's not that big of an issue, but it's the sort of thing where I remember thinking when I set this up in SolidWorks, I remember thinking, I only need to do this once, so I don't need to focus on it too much. But afterwards, I made so many changes to things, and I needed to keep referencing those sketches, so it was handy to have them there in like a way that is, I don't know, sensible with the rest of the CAD package. But this works for now. Yeah, so I was able to get those geometries, and I've updated the rest of everything, so now I can control everything properly, and everything knows where it should be, which is very nice. Cool. All right, so the next thing that I went to do was to update the homing sequence, and just to make sure that everything could home properly and that, yeah, it was all working fine. And I had made some changes between when I last operated Jugglebot as its entirety and now when I have the hand motor and the whole Jugglebot. So in between there, I was doing stuff with just the hand. I was just like leaving the legs where they are and just operating on the hand. And when I was doing that, I realized that there's a way that I could simplify my homing sequence where I can kind of split up its functions into 2 functions, where I now have one function that takes in an axis. I'll say I want to move, I got an axis or a motor. I want to move motor number 4, and here is the current limit, and here is the direction and the speed that I want you to move in, so, and just move. And that function will move that axis at the nominated speed until the nominated current is hit. And then it will say, yep, cool, this is done. And then we'll go back to the main homing sequence where it will then find the next motor and go through the whole thing again, which is all working fine for the hand. However, for some reason, when I went to do this on the whole robot, it just wasn't working. And I was scratching my head for so long. This was driving me so mad, and I could not figure out what was going on. I had got it down to, so this wasn't here. This time.sleep wasn't here. So let's pretend that that's not there for now. What I was experiencing was I would go through, this command would get sent. So all of these like set requested, like set, anything that's like set or send is a call to another function that sends a message over the CAN bus. So this message, and I can poll that CAN bus with other methods and like other ways, and I can see those messages coming through. So this message came through, this one came through, that was fine. This one came through, and then the whole thing would stall. Nothing would happen. The whole thing would either nothing would happen and it would just sit there and just be waiting for something, who knows what, or in some cases the motors started just vibrating really fast. Sometimes they just like, I don't know, moved a bit randomly. It was just so confusing. And so the problem was that the message that actually told it to start moving just would not get sent. So if I had a CAN, like a CAN monitor open on the Jetson itself, which is the thing that's sending the messages, that would register that message as having been sent. But the O drive would never receive it. And then the Teensy, which is right next to the O drive, would also never receive it. Like, what the heck? Turns out, having just this little time.sleep is enough. And as soon as I added that, all of my problems just magically went away. I still don't really understand exactly what's going on here, because the CAN bus should have a buffer of, I think the default is like 10 messages, where it can hold those 10 messages. And if you are sending messages quicker than it can respond, or quicker than like the messages can be read, then they'll just sit in that buffer and fill up that buffer until they can get sent out, and then it will like work its way through the buffer. So I don't really know why this time.sleep is that important, because I'm not sending 10 messages here. There's only like 4. I don't know. Maybe, I don't know. But it works. So yeah, that's not a problem anymore, which is good. Yeah. I just want to say as well, I want to have a quick little interlude. There's a link in the description where you can access the GitHub for this project. And I just want to show you where these things actually are on that GitHub. So the link should take you to here. I think it's in the main branch actually. But if you go over to the develop branch, then the things that I'm going to show today are all in ROS workspace. If we go into source, into Jugglebot, the Teensy code, this is what I'll be showing some of very shortly. This is what's operating on the Teensy. So right now, this is like monitoring the CAN bus, as I've talked about before, and it's also doing some very important roles in the leveling, which I'm going to show in just a sec. And then also, if we go into Jugglebot from here, then this is where all of these scripts are, if you want to check them out. Yeah, cool. So the next thing is how to level the platform. So this was my main task for the week, is to get Jugglebot so that it can start at some weird angle and then figure out that it's at a weird angle and fix itself up so that it's flat. And this, if it's not obvious, this is very important for juggling, because if Jugglebot thinks that it's flat but it's actually tilted at a very slight degree, at a very slight angle, then when it throws the balls, thinking it's going to be throwing them straight up, it's going to be throwing them at a weird angle, and even for small angles, the ball just goes really, really far to the side. And so we need it to be as flat as we possibly can manage, or when it thinks that it's flat, we need it to be as flat as possible. And so we need some way to do that, some way to level itself out. So let's see if the camera will work. And I want to show you this before working through the theory of it, because I think it's quite cool. And I spent a lot of time trying to get this to work, and I'm glad that it does now. And yeah, but the camera doesn't seem like it's going to be working. So let's do this. I'm going to move this camera over so you won't be able to see me anymore. So we've got Jugglebot here. It is on a box on a weird angle. This is obviously not what it would actually be set up like in real life. Let me just turn things around so that it's a little bit more obvious what's going on. Yeah, that should be pretty good. Why are you not focusing? Oh, that's good. Cool. All right. And I also want to show you this so you can see what I'm doing on the Jetson. So let me open this up. There's always so many things to worry about. There we go. Cool. So you should be able to see the Jetson view and Jugglebot. Let me make Jugglebot a little bit bigger, because the main thing I want you to see is the window on the top left. All right, so we can turn everything on. And, sorry, just give me 1 second. There we go. Yeah, so Jugglebot's on. We can start it up. And it goes through its like index search, so all of the motors will move just a small amount, which is a bit freaky when it's on this angle, because sometimes they move a little bit too far and the whole thing kind of like falls over a bit, but it's all right. Cool, and then we can send some service messages. So the first one is we want to home the robots, home the axes. And so we'll go through, it does all 6 legs and then it does the hand. And previously the hand would home by going all the way down and then all the way up, and it would figure out its like stroke length. But now I only had to do that once or twice before I knew what that length actually was. So now that's hard coded and it just goes down and then it knows what its limit is because I've set that. All right, so we've homed. Now my thinking for calibrating is, let me go into camera view. That kind of works. No, not really. So my thinking for calibrating is, I'm skeptical of the legs' ability to be exactly where I want them to be at all times. Just, I don't know, it's probably unwarranted, but that's the case that I am. So I'm thinking that the most relevant calibration that we can do right now, if we're only going to do one calibration, the most relevant one is to get it to go up to the height that the platform will be at when Jugglebot is juggling. And then we can take a single calibration at that middle spot, and then hopefully wherever the platform moves at that same height, that calibration should be fairly valid for all of those movement points. I am potentially expecting at some point in the future to have to do like a probing thing where it will move around to a bunch of different poses at that height, and then get like it'll have like a mapping of like, okay, if you're at this pose, then you need to apply this calibration. If you're at this pose, you need to apply this calibration to be exactly at the angle that you want to be at. But for now, just one reading, and it feels to me like the most relevant reading will be the one where it's at the height where it is juggling at. So I have a service call for move to calibration pose, where it will move up to roughly the height that I think it should be juggling at. And then we can, where are we? Calibrate the platform tilt. So what this does is it polls the inclinometer that's on the back of the arm here. That sends its measurement off to the Arduino, off to the Teensy, and then the Teensy sends it over CAN to the rest of the code. And we can see here that the first reading that we received was 3.14, 3.14, which I have set in manually in the Teensy code as basically like an error detection method. So I'm saying if the reading is wrong for some reason, then send 3.14, 3.14. Like if it's like outside of a certain range, if it's like too far, if it's too steep of an angle, then send this, because that Jugglebot should never be at an angle that's more than like 45 degrees. So if the reading is like weird, then just send 3.14, 3.14, and that way we know that there's an incorrect aspect of this reading. So then what the code does is it says, hey, this reading is invalid, so now I'm going to ask for a new reading, and then it sends it out a second time. The strange thing is, this happens very often. Very often, the very first reading that I take at any given instant is this 3.14, 3.14. So there's something going wrong in the code. And actually, I mixed myself up a little bit. In the Teensy code, whenever it says 3.14, 3.14, that means that the inclinometer had to be reset and the reading wasn't able to be taken. So I think potentially the inclinometer actually might need to be like kept in an inactive state when I'm not interacting with it. And then when I do interact with it, then I want to activate it, take the reading, and then deactivate it again. I'm not currently doing that right now, and I think that that might be why this is happening. But in any event, having this resend request thing seems to be working. And by the way, this is in radians, not degrees. Yeah, so we can see right now we are at 0.07 and, well, negative 0.07 and negative 0.14 radians, which I have open on another screen is roughly 4 degrees and 8 degrees. So it's fairly far off being flat, which we can tell because it's on a massive angle. But then, so yeah, the second part of this calibrate platform tilt service is that it will take that angle, those 2 radian measurements, convert it into a quaternion, and then it will send that quaternion to the ROS network, and then the node that is responsible for positioning that's responsible for doing the Stewart platform inverse kinematics, which is basically, I tell this platform where I want it to be, and it figures out how long the legs need to be to get us there. That code, well, that node, listens to the quaternion offset topic, and then it applies that offset for all future commands. So that offset has already been uploaded now, like it's already been sent over the ROS network. And so now we can just, again, a second time, move to the calibration pose, and it will flatten itself out. Strangely, this doesn't work really precisely every single time, like first try every single time. So if we, again, calibrate the platform tilt, again, we get 3.14, 3.14 for some reason, and we're still tilted. So we're still tilted by 0.05 and 0.02 radians, which is 3 and 1.2 degrees. But we can again move to the calibration pose, and then we can do this again. Calibrate again. So now we are at, let's go 0.4 and 1 degrees. So we can move again. It'll do a little straighten up. Calibrate again. We are now at 0.4 and 0.1 degrees. That's pretty good, but let's move it one more time. Yeah, very, very small correction there. I don't even know if that would have shown up on the camera. But now it's fairly flat, and now I can poll the CAN bus without having to do any of the ROS stuff, and I can see that we are at 0.01 and 0.19 degrees, which is pretty good. And every time I do that, it's slightly different. So I think, oh, actually, I've got a lot of stuff to talk about in a sec. But for now, the one thing that I really like about this is that if I go into the Jugglebot GUI, so let me show you this as well. So we don't really need to see the Jetson view anymore. So let's do this. Yeah, you don't need to see them. I do need to update the GUI. You will see in just a sec that the some things are definitely not correct. But if I go into Space Mouse mode, the Space Mouse is disconnected. All right, actually no, we can do jogging mode. That will work. So yeah, the Space Mouse was disconnected when I started this up. So if I want to show you the Space Mouse thing, I'm going to have to turn everything off and then do it all again. I don't really want to have to go through that whole process again. But the jogging should work. Where? No, what? All right, I don't know why this. That's weird. All right, I don't know why that's not working. But so you have to take my word for it that whenever I send commands to Jugglebot to move, for all commands in the future, this is its like 0 position. So even though the base is on some like cooked angle, this is its 0 position. So when I move it forward with the Space Mouse, it just moves perfectly forward. If I move it to the side, it moves perfectly to the side at this like tilt offset, which is extremely nice. So this means that for all future commands that we send. So if we have like a juggling routine for it to run through, it will say, yep, this is home. I don't really care about the fact that I'm on some wacky angle right now. That doesn't matter because I've calibrated for that. So now I know that this is 0, and now I can do my whole juggling routine and I will be flat the whole time, hopefully. Yeah, and of course I can turn it off and it all goes down and calmly puts itself to sleep, which is very nice. I'm a big fan of this. Yes, so let me fix my windows up, and I have some other things to discuss. Where are we? Let's just do this. Cool, yeah. Let's go through this first. So yeah, to recap, the whole thing is that we move up to the calibration pose, take a reading from the inclinometer, save that reading as a quaternion, apply the inverse of that quaternion to all future pose commands, because of course if we applied what that reading is, then we're just going to be doubling that angle, so we need to do the opposite so that we like counter it out, and repeat if needed. But the question is how to do this automatically, and this is where I was stuck for such a long time yesterday. I was very frustrated for quite a while trying to get this to work, because I was fixated on the idea of doing this all in one node. And the node that I wanted to do this in is the CAN bus handler node, which is the one that handles all of the communications that go through the CAN bus, which, if you remember, is the thing that's actually controlling the robot. So yes, this was tricky to do all in one function, because for that to work, what we need to do, the thing that I was stuck on for a long time yesterday, is how to know when the platform has stopped moving. So we command the platform to move up, that's all well and fine. Once it has stopped moving, we want to take a reading from the inclinometer and then go through that whole process of like calibrating, move. But we need to know when it has stopped moving. And I could not figure out how to do this. So what I wanted to do, my goal was to move up, pause the function from operating while keeping the rest of the node running in the background, because the rest of the node has to run, because that's what's actually commanding the robot to move. Like that has to be running so that the robot can actually do the movement. And then once it has completed the movement, then continue running the rest of that function. And yeah, I asked ChatGPT a bunch of different ways to do this. One of the suggestions that it had was using this async IO Python library. And I was like, this feels weird. This doesn't feel like a ROS thing. Like it feels like kind of like the threading stuff. It feels not right. But I asked ChatGPT, like in that same session, I was like, okay, this feels like it might work, but like, is this really like a ROS best practice to do? And it was like, yeah, async IO, that's ROS, that's normal for ROS. And I was like, all right, okay, I believe you, let's keep going. But then after a little while, I was a little bit skeptical about that. I asked a new instance of ChatGPT, is async IO like a normal aspect of ROS work? Like, would you expect to see it in ROS projects? And it was like, no, not really. I'm like, I've been lied to. Honestly, it feels, so I've obviously used ChatGPT a lot, and it feels like it goes like it ebbs and flows in its utility, and it feels like for me at least it's in a bit of a rut right now. It's feeling a little less useful than it has in the past. Like this, it's like, yeah. So I did a lot of Google searching of like, how do I pause a node at one spot while keeping the rest of the node running in the background? And there's all this stuff about like spinning the node manually, but none of that ever worked for me. But I should have realized, and I realized finally last night, that given that I can't find any good information about how to do this, that's probably an indication that I'm doing the wrong thing and that there's a better way to do what I'm doing. And I made that connection after I had decided to just like, I'm like, stuff it, whatever, I'm just going to separate it into different services, and that's what you saw just then. So what I was trying to do before was just have one single service. So I'll go calibrate platform, it will move up, take the reading, offset, take the reading, offset, do that as many times as I need until it's down to some tolerance level, and then it'll be done. Then I was like, no, I want to have something ready for the stream. I want it to work kind of okay. And by that point, I'd never even tested the reading at all. Like I had spent hours trying to figure out when the platform had stopped moving, and I had never actually tried the offset calibration at all. Thankfully, that actually worked really, really cleanly. It just worked. It's good. It's very, very good. Yeah, but yeah, it's obvious now in hindsight that splitting this up into different methods is a good way to go. And so what I'm thinking, so I obviously want to do this manually. I want to do this automatically so that I don't have to sit here and watch it and go, okay, cool, now it has stopped moving, now I can take the reading. I don't want to do that every single time Jugglebot starts up, so I want some way to do this automatically. And I'm thinking that if I have a completely separate node, this feels like a good time to do like Jugglebot brain node, where that brain node, because it's separate to the operation of the CAN bus, I will be able to pause that one, and it will just be able to sit there and wait and get updates on the status of the movement. And then once the movement has complete, then it can keep going. That node is completely fine to pause, and it can just sit there and wait for as long as I need to. It won't hinder the operation of anything else. So I think that that's the way to go. So I have a separate node that basically calls these three services that I just did myself, but it will do them automatically. Hopefully. We'll see. That's my plan for today after the stream, is to get that working so I don't need to do it manually anymore. Yeah. Jean-Marc says, do you plan some limit checks regarding the Quaternion offset? Depending on the angle delta, some positions would be unreachable for the platform, wouldn't it? Yes. So that's one thing that I would have loved to show if the jogging was working just then. But I have, at several stages throughout the ROS code, there are checks to make sure that none of the legs are over or under extended. And yeah, and those checks are always working. So even though this pose offset tells us that the 0 point is potentially here with respect to the base, the legs are still handled as separate individual entities. And if any of those are over or under extended, then they will not, they'll be clipped to that limit. So yeah, none of the legs will over or under extend. However, I haven't put in any of the considerations with respect to collisions, particularly for the bottom of the platform. As I've shown in the CAD before, the bottom of the platform can hit the legs if it's at really aggressive angles. So I haven't done anything with that. And actually last night when I had this at a much, much steeper angle just to see what it could handle. And yeah, this will be somewhat visible. So the 0 point was here, say, and it was not that hard to get it to be in this sort of position where it's in a singularity if this is all lined up. So once that reaches that sort of angle, it's very, very unstable. I don't know if you can, hopefully you can see that sort of well. But yeah, there are angles that it can reach, and actually this would have collided if I was just that's colliding there. Yeah, I haven't included any of those sorts of things yet, which is a very good point. But the problem is that I don't really know how to do that. I don't know how to tell it that those particular poses are bad. I don't know how to figure out what specific poses are actually bad. So my thinking for now regarding that is to just run all programs on Jugglebot at a very, very slow speed once, just so that I can get a feel for how they're going, and then run them at full speed and yeah, get it to actually run. And hopefully there's no bad collisions. Josh says, definitely separate nodes. A good rule of thumb is if you can't say what a node or function does in a simple statement, it's doing too much. Okay, yep, that is a very good point. Yeah, and yeah, Josh is also saying, it sounds like you came to a good solution. You had good Spidey sensors regarding async IO in a ROS node. That's good to hear. But one thing that I've been doing a fair bit of reading. This is completely separate Jugglebot, but I've been doing a bit of reading into, I don't know, how the brain works and how we think of things. And specifically with reference to gut instincts. And the finding that I keep running into is that gut instincts are extremely useful if they are built on experience. However, gut instincts for novices tend to be just like all over the place. Like it could be right sometimes, or it just could be completely off. So despite you, I don't know, making my spidey senses or gut instincts, well, suggesting that that was correct in this case, I'm actually I'm starting to try to distrust not distrust, but like put aside my gut instincts regarding code stuff for now. I don't feel like I am at a level yet where my gut instincts are actually informed on much. So I'm trying to go off of like, is this actually sensible? Can I explain this? Is this reasonable? But yeah, that's easier said than done sometimes. Yeah, so the last thing I want to show is the new ROS network graph, just to like, I don't know, keep you updated with what's actually going on. So some of the things that are evident here, let me get rid of me. This diagram is obviously, there's a lot going on here, but I don't know, to give a good overview, this is the GUI basically. So everything goes into the GUI. So that's very integral to everything else. All of this stuff, this is going to be changed very shortly. This is all relating to the hand and like the juggling pattern controller, which will absolutely exist, but that all needs to change because that's all based on what the hand looked like before. The new things now, just so you can see how I've actually set this up, CAN bus handler node is the one that is currently doing that whole calibration sequence. So those 3 services that I was calling before, they are all in CAN bus handler node. And the end result of that is that it spits out the pose offset to here, and then Stewart Platform Inverse Kinematics receives that. So this Stewart Platform Inverse Kinematics is the one that takes in all of the pose commands that we're going to send Jugglebot to, and then it sends them out to the leg state, the leg lengths topic. This leg state one is the one that tells us if they're too long or too short. But the leg lengths topic is the one that's actually telling us how long the legs actually need to be. And then that goes out back to the CAN bus handler node. This shouldn't be like this, but this will go to CAN bus handler node, which then goes off to the motors. So the CAN bus itself is not on here, but that's like hidden inside this node. Yeah. So once I change this over, there'll be a new node that is like, I don't know. Maybe I'll just call it. Right now it's just going to be doing the alignment stuff, and I don't know. If I'm following what Josh has suggested, then maybe I'll keep it only ever doing that alignment stuff. But that'll be over here doing the alignment. That will send to pose offset, which goes to Stewart Platform Inverse Kinematics, which will go to the leg lengths, which will then go to the CAN bus. So it'll be nice. No more overlapping stuff. Yeah, lots of nodes, lots of topics, but we're getting there. Yeah, so my plan for my next immediate plan is to get that all working so that it is automatic, and I'll have some like tolerance level where I can say, okay, if the angle reading is less than 0.5 degrees, I don't know what I'll set that to, but whatever it is, it will just like step through that again and again and again until eventually it stays flat, and then we can move on to the throwing testing. Now there is one thing that I want to mention right now, which is the gremlins. The gremlins that are lurking in this project right now. These gremlins, I don't know what's causing them, and I don't like them. So every now and then, there will be one motor, so far only one at a time, that just doesn't push. And so I'm only talking about the leg motors right now. The hand motor is not really doing anything, but there'll be one motor that just doesn't have enough oomph to move the leg that it's attached to. And it's so bizarre. Like if I look at it in the ODrive GUI, I can see that it's being commanded to move, and it's like its IQ set point is like the limit of what it could possibly be. But it just doesn't move. And like I can sit there and I can feel that it wants to move. It wants to push the leg, and I'll just help it along. But it just doesn't have enough like power to stay where it should stay. It's really bizarre. the way that, so previously, this was motor number 2 was doing this, and I'm like, all right, this seems strange. Maybe it's like an ODrive config thing. Maybe there's something weird has happened in the config. So I exported the config from a working ODrive and then backed up that config onto the, like restored that config onto ODrive 2 and then ran through the whole calibration sequence and everything, and then it was working. And I'm like, cool, okay, that seems to have fixed it. I shut everything down, put everything back on, and now it's motor 4. Like, what? So I did the same thing. This was just this morning. I did the same thing, like put the new config on, ran through the ran through the whole calibration sequence, and that seems to be working now. And so far, the Gremlins haven't moved to a new motor yet, so they all seem fine now. But like, I don't know. It's really weird. I was thinking maybe it was caused by there just not being enough power available on the bus, because that regen clamp that I'm using right now, I'm still waiting on the big soldering, I'm still waiting on the big soldering iron tips to finish off my regen box from last week. So I'm still just using the one that I bought, which is a limit of 8 amps out, like 8 amps out to all of the motors. So I was thinking maybe like that's not enough power for all of them. So I actually took that regen clamp out and just went straight from the power supply to the robot, and that didn't fix it. So I don't know. It's strange. At least I have a way to fix it, I suppose. But it's kind of annoying because plugging in the USB-C cable into the ODrives it's in a really awkward spot with how I've put the ODrives in. So I don't like that solution, but it works, I guess. 24/7 testing says, hey, any chance you're going to make a regular video update on this project anytime soon? Yes. Hopefully. So my plan is to have this done soon. So the TLDR of my feeling on this is that I feel like Jugglebot is very, very, very close. I don't know how much you've seen in the last few updates, but John, one of the regular viewers of the channel, has taken a particular interest in the project, which I am extremely appreciative of, and he has done a lot of work on getting the hand to throw and catch well. So we have a really good routine that the hand can run through to throw the ball up and move down to receive the ball at the right time. And that is my next step. So after I get this homing sequence automated, my next step is to integrate his work into getting the hand to throw properly. And then once that's done, it should just be a matter of combining that with just moving the platform, and we should be juggling. So because this feels extremely close, my thinking is that I want to wait on making like a proper video until this works well enough that I'm like happy to have it be like the main video for this version of Jugglebot. And what I want that to look like is probably 3 balls in one hand for this version of Jugglebot. At least 2, definitely. But yeah, I want to get it to that sort of level before I make a new video. And that video I'm expecting to take a long time to edit. Honestly, any video that updates people who haven't been watching these live streams on what I've been doing is going to take a long time for me to edit, because a lot has happened. My last main video, I'm pretty sure, was on the linear actuators. And that was what, like 7 or 8 months ago? And I've been working a lot on it since then, like most days for many hours. So yeah, there's a lot to cover. And so I'm expecting that editing to take a long time. And I don't want to lose the momentum that I've got right now to getting it to work, if that makes sense. So I want to get it to a point where I'm like, this is really good. Like, this is obviously cool from like a layman's perspective, and then I'll make the video. Fingers crossed the video comes out before the end of the year, but we'll see. There's lots of things to do before then, so yeah, we'll see how we go. Yeah, there's definitely, I fully appreciate that the live streams are not for everyone. They definitely, yeah, it's a lot to keep up on. Yeah. I wish that there was some way for me to make, I don't know, like Wintergarten, I don't know how many, I'm sure many of you are familiar with Wintergarten and his marble machine. He, for a little while, was doing live streams, I think like every day. He was doing a lot of live streams, But then like once a week he would upload like a summary of the week, and that was like a 10 or 15 minute video of just like what happened in the week. I like that idea, but he must have spent so much time editing videos if it was him doing it. Someone must have been spending a long time editing those videos. And I just don't have the time to do that every week or like regularly. So I don't know, it's tricky. But yeah, hopefully soon. Yeah, rest assured, work is being constantly done and we're getting there. We're getting there. Day by day. Yep. Thank you for the kind words. Yeah, so as always, if you have any thoughts or anything about any of this, please let me know. If you want to help contribute in any way, I would suggest checking out the Onshape document there's a link in the description of this live stream, and you can have a look around in there. The one thing that I would like some, I don't know, that I fully intend to do but don't really have, I don't know, the motivation or like immediate need to do right now is to fix those bellows. So I did actually do so the bellows, for anyone who can't remember, similar to this, but tapered, and I can't print them anymore because the overhangs are a bit too steep. I printed off this overhang test that someone in the last live stream suggested that I test out, and I can get to about 30 degrees. 30 degrees is here, and we can see there's a bit of a, let me see if we can focus. There's a bit of an artifact there, but the strange thing is, I don't know if this is like a normal printing thing, but it seems like so the print head goes down, and it looks like it's like pulling, when it turns around and like goes back the other way, it looks like it's like pulling the filament back over itself and leaving these really nasty artifacts. I don't really know how to fix that. If anyone has any thoughts, I would love to know. If you want a better photo of this, let me know and I can upload one to Zulip. But yeah, 40 to 50 degrees definitely seems like the limit. But this isn't like a fully accurate representation of what the bellows would actually be, because the bellows can be printed in vase mode, where the nozzle never needs to lift up, so it can just continue to. So there won't be any of this like ripping up when the nozzle moves. I don't know. Yeah, it's weird. I have a feeling 45 degrees is probably about the limit that I can get to with TPU on my printer. Yeah, but it's different with the bellows because it's a different shape entirely, so who knows. But yeah, cool. Oh, there's another comment. Someone should go back and edit your live streams into a shorter video. That would be great. If anyone wants to do that, I would absolutely publish that. Like, yeah, but it's a lot of work. Yeah, that's actually one thing that I like about these live streams is that I will be able to go back through them. Like, this is kind of providing content for the main video that I'll be making later. So I will eventually be downloading all of these. I probably should be saving them as I'm streaming them to get like a local copy, but I don't think my computer can handle that all at the same time. Yeah, so it's good, like good material that I'm amassing here, but it's going to be a lot of work editing it all. Yeah, Peter is suggesting, have you tried introducing some Z-hop? Interesting. That actually, yeah, true. That might help with this. So I've actually been thinking that the Z-hop might have actually been causing issues with the bellows when they're printing because there's too... No, actually, yeah, you're right. It would be too little. So the issue that I was experiencing with a lot of the bellows when I wasn't doing it in vase mode is the same sort of thing. Like when the nozzle moved, it would bend the already printed bellows over just a little, just enough so that when it like met where it's going to start printing next, it would not be perfectly lined up. And because that wall is so thin, it has to be like it has to be perfectly on. But you're right. Yeah, I think vase mode is probably the way to go though, because it looks nicer as well because there's none of those little artifacts, like the little dimples of where it starts and stops. Yeah, we'll get there eventually. Yeah, cool. All right, thank you for watching. I hope you found it interesting, as always, and I hope, yeah, good luck with everything that you are working on yourself. Vase mode, yeah, vase mode I think would be best. Yeah. if it will just work. It's so frustrating. Like, you just press print and then I feel like I just have to sit here and watch it because it could fail at any time. The whole thing, it's like 2 hours of printing. At any point, it just could stop. I don't like printing those. I don't know, it pains me. But anyway, yeah. Cool. I will see you all next week. Hopefully, we'll be throwing. Big fingers crossed. Once this leveling is working, hopefully the gremlins stay far away, or, I don't know, in their caves, wherever they live, not in my motors. And hopefully we'll be throwing. We'll see. I know I've said that a lot though, so yeah, we will see. Cool. Till then, have a good one.